Welcome to video 12-4B. This is the second in the series of 3 videos for lesson 12-4. We're looking at Explain 2 on page 666 right now, and we're going to be talking about some geometric means theorems that apply when we have altitudes, that's a right angle forming segment that is drawn from the corner right angle to the hypotenuse of a triangle. So let me say that again. Here's our right triangle. This H here is what we call an altitude, and the altitude is drawn from one vertex of a triangle to perpendicular to the opposite side. So when that happens in a right triangle to begin with, when we have an altitude here coming from the right angle down to the hypotenuse, or over to the hypotenuse in this case, what happens is that we have 3 different similar triangles. So I'm going to take some time and take this diagram apart right here into the small triangle, the medium triangle, and the large triangle, if you'll bear with me. So let's move over into our margin a little bit. This diagram right here, we can go ahead and break down into small, medium, and large, or baby bear, mama bear, and papa bear, if you want to think of it that way. Our small triangle, right triangle, is going to have side lengths from this diagram. This is my shorter leg over here of x, the longer leg of h, and a hypotenuse of little a, the way that this diagram is labeled. And again, that's just pulling this right triangle around and putting that right angle in the corner. We're going to orient all the triangles the same way so that you can see them kind of compared and see how these proportions are set up. Then we have our medium-sized triangle, and again, there's our right angle corner. So our medium-sized triangle has as its shorter leg actually h, the altitude. Then we have its longer leg, they're calling y, and the hypotenuse of that medium triangle is going to be letter B. Then our papa triangle, or large triangle here, the biggest triangle that we have its short leg is A, its long leg is B, and its hypotenuse is C. So hopefully those labels are familiar to you from your Pythagorean theorem. It's just that we have 3 different triangles that are going to be similar to each other. So as we're looking at those diagrams, we can think of setting up proportions of corresponding sides in the following way. Between the small and the medium triangle, if we looked at the ratio between their short leg and longer leg for each one, we would be able to set up the following proportion, which is x to h equals h to y. To compare the small triangle to the large triangle, and let's this time compare our short leg to the hypotenuse, and again our short leg to the hypotenuse, we could set up the following proportion. We could set up x to a is going to equal a to c. And then for the final comparison of our medium triangle to our large triangle, we could set it up so that we were comparing the hypotenuse to the long leg and the hypotenuse to the long leg. So the following proportion would result from that. B to y is going to equal C to B. So that's just a little bit of background of how those similar triangles all come together. Now hopefully it'll make a little bit more sense as we move over to our theorem. Our theorem says the length of the altitude to the hypotenuse of a right triangle, remember altitude to the hypotenuse is this h, is the geometric mean, and we now know that that's solved by taking the square root of the product of these two values of the segments of the hypotenuse. The segments of the hypotenuse there that they're talking about are x and y. So you can see on the diagram, if the altitude h splits that hypotenuse into x and y, then I can find x by taking the product of x times y and finding its square root. And that comes from this proportion up here, you guys. X times y equals h times h. So that's going to give us our geometric mean there within the triangle that way. Then the other theorem that we're going to use is that the length of a leg of a right triangle, so in this case we would say A, would be equal to the geometric mean of, this is a little tricky so follow this wording carefully, of the lengths of the hypotenuse, so if we're finding A, the hypotenuse is C, and then the segment of the hypotenuse that's adjacent to that leg. So A is adjacent to x, and if we're talking about finding B, B is adjacent to y. So look at our other two proportions that we have there. If we're finding A, let's look at this bottom proportion, we're going to have A squared equals x times C, and then its square root then is the small piece times the whole hypotenuse to find our leg A. Same thing for B, comes from our second proportion that we set up here. B squared is going to equal the whole length of the hypotenuse times cy here. Y is the part of the leg that's right next to the leg B. So those are the three theorems that we are going to use. We're not actually going to go through the proof, but I wanted to make sure that those theorems were clear before we start using them on the next page. Okay, we're on page 667 with Explain 3, and we're being asked to find the missing values of the triangle diagram that we have at the top here. So first we're going to find x, and notice x is the altitude drawn to the hypotenuse. So we're going to write a proportion. Remember, it's the geometric mean, or the square root of the product of the other two pieces of the hypotenuse. So 10 and 2, it's the geometric mean of 10 and 2. So we're going to set up our proportion 2 to x equals x to 10. Cross multiply, we get x squared equals 20. And taking the square root of 20, we get 2 radical 5. Because remember, we can pull that square root into its two pieces of square root of 4 and square root of 5, and the square root of 4 simplifies. So now let's fill in for part B using the same diagram here. We're going to write a proportion to find y this time. Now, y is not the altitude like it was for part A. Y is a leg. So the proportion that we're going to set up there, and we want to kind of remember which part of the hypotenuse is y adjacent to, it's 10. So we're going to say that it's the product of 10 and 12, which is the whole hypotenuse length. So we have y squared is going to equal, I'm just going to skip these middle steps here and go right to the cross multiply. Y squared is equal to 120. Taking the square root, y is the square root of 120. Again, might make sense for us to do a little factor chart there. Really quickly, 120's factors are 120, 260, 340, 430. 5 does go in because 10 does and leaves an even number. 5 goes in 24 times. 6 and 20. I still haven't seen any perfect squares in this column anyway, over on the right hand side, which is the bigger column. So let's keep going. 7 doesn't work, 8 does. 8 is 8 and 15, and then 10 and 12. So there's absolutely no perfect squares in that larger column like we had hoped. So as I think about moving around from largest to smallest, the actually only perfect square in our list there is 4. So we can break that down only as far as square root of 4 and the square root of 30. 30 doesn't have any other perfect square factors, so this is 2 radical 30 when all is said and done. Alright, you only have one your turn problem at the bottom of this page for this video, and that's number 10. Take a pause right now before you go on to the next video and figure out what you are missing for finding x here. X, remember, looking at it in the diagram, that is the altitude, so think back to which part of the explain 3 we should model that after. Alright, we'll see you in the next video.